Hello guys, welcome back to CFS video tutorials. In this video tutorial, we will go through a multi-story Xbrace shear wall design. Let me go to my CFS, and so what I'll do is I'll go under Xbraces and I'll select stacked. Okay, the maximum stories I can go is total 8 stories. Now I have 8 stories of shear wall over here. Let's say I have 8 stories of building. Now the first thing is inputting the loads. So you can get your loads by doing torsional rigid diaphragm analysis on the building using NRCalc software or ETABS. Okay, so once you know uh, what load is coming on each floor at center of mass of the diaphragm, that load gets distributed to all the walls, all the shear walls in a building. So now let's say I have a 30-foot shear wall everywhere. Okay, so I divide it into 3 panels. So I say 10 foot each panel, and my height of the shear wall will be 10 foot on all the levels. Okay, now over here you can select your codes and design method. I'll be selecting ASD, or you can even select LRFD if your loads are based on VUltimate. Now the next thing I will select is I'll select all this as 1 because I think it won't let me select 0. Yeah, so I don't have any seismic load. I'm only doing for wind load right now. If you have seismic, you can have seismic over here, and you enter your overstrength factor, CD factor, SDS, seismic design category, everything over here. Now I'll start with my wind load. So I have 5,000 pounds at the top, and it goes to 2,500, then 2,200, 2,000. All these values are some estimates that I'm taking right now, because in reality you get these values once you do the rigid diaphragm analysis. Once you do the rigid diaphragm analysis, you get your loads in the walls and you divide it by 3, so you get a 10-foot panel load. Now once that is done, I don't have any additional applied chord axial loads, and I don't have any additional applied chord moments. Now you can see your member summary over here. Now all this is failing, so we shall go to strap data. Now let me select my strap to be on both sides of the wall, and let me select 6 inches width of my strap. You can manually select bigger straps if you want, you can just enter 10 inches like that, or 6 inches. You can manually enter 6 inch if you want. Even my net strap width would be 6 inch. Now coming to my strap thickness, I'll be selecting it as 16 gauge because I need 16 gauge strap thickness. You can select 18 gauge, just make sure you try with a higher one and then go to a lower one, because it might work in some cases, it might not in some other walls. So you'll need to design for a maximum wall load condition. Next, coming to my FY, this would be 50 KSI, because it's a 16 gauge strap thickness. Minimum 50 KSI needs to be provided. my RY value, as you can select this question mark and you can figure it out. If your Fy is greater than or equals to 50 ksi, Ry and Rt will be 1.1. In other scenarios it will be different factors. So I'll select 1.1. Over here, if my Fi is 50 ksi, my Fu will be 65. Nothing but ultimate stress. So this will be 1.1 again. Now we need to enter this information for the strap to work. Alright, let's check it again. I need two sides over here. So two side strap, 50 ksi, 1.1, 65 ksi, 1.1, 6-inch strap, 0.0566 inch thickness. Now once the strap thickness is done, we can go to cord, track and hold down data. Now this would be my cord studs and it would be my end studs, nothing but how many end studs would be required. Now let me just, so flexural operation would be midpoint. I'll be selecting everything as midpoint. Alright, everything being selected as midpoint. That's good. Hold down and tie data. This, I would suggest you design hold downs manually, because over here it doesn't consider the dead load of the wall when you design for hold down. Now going to let me show you something before I start entering my end studs. So now, as you can see, my strap data is fine, it works everywhere. Now coming to my cord interaction, this is bad. Now you need to enter your cord members. So let's start with 600S 162. Let's do 43 back to back. So this is configuration where you can enter 2 configuration, 3 and 4. So I'll select back to back. Okay, this would be my screw spacing, 12 inches on center. Now let's go and check. So as you can see, the cord interaction went to 0.44. Let's do the same thing for the next level. And see if it works. It doesn't. So I need to move it up. I need to go to 16 gauge. Okay. Now next thing I'll do is I'll give 62, 54 and I'll select 3. Now as you can see, the ratio went down. Similarly, I'll select 162, 54. Now this needs to be 50. Even this, even this. Let's try this as boxed. It still works, which is good. Now next thing, I'll select 162, 68, or like what I can do is like I can select 54 and 50 KSI. I can have 4 configuration. So you can see 4 configuration gives me 0.95 ratio. So I definitely need to select either thicker flange or thicker gauge. So let's do 600 S200 54 and 50 KSI. This would be 4 configuration. Similarly over here. Let's go back and see. So you can see they are still failing with even thicker gauge. So what I'll do is like I'll use 68 instead. Let's see. Yep, even 68 doesn't help on lower 2 levels. Let me go for a thicker flange and 68. That's good. 5% is allowed. Now as you can see, this is 1.24. okay, so 1.24 interaction ratio for 4 end studs. Let's see for 3 end studs. So now for 3 end studs I have 1.65. so if I use 6 end studs, that would be definitely less than 1. So this is how you like decide the quantity of end studs required. So on top 2 levels, actually 3 levels I need 2, whereas then on the 5th level I need 3, whereas on bottom level 4, 3 and 2 I need 4, and on level 1 I need 6 on the basis of the interaction ratio. As you can see, it's 1.65, and if I mean 3 can only take like half of the 1.65. Make sure the track data you input is right based on the stud. So whatever the gauge of the stud you are using, that would be the gauge of the track they need to use. So all this I will keep it as same. I'll just change the gauge. 43, this becomes 54, 54, 54, 68, because the gauge is what decides the screw quantity. Thicker the gauge, lesser screw quantity is required. So once the track data is inputted, stud data is inputted, and as you can see, we don't have any issues. Like this 1.01 is fine. 1.65 we have 6 end studs, so that will work perfectly. Now going to connection data. So in here you have connection types as welds, strong drive fasteners, or generic fasteners. Typically they use generic fasteners everywhere, so we'll do generic fasteners. And as I have taught you in simple Xbrace shear wall, the screw connections would be either for vertical and horizontal. Vertical meaning the number of screws required on the studs, and horizontal number of screws required on the bottom track or top track. So I'll be selecting vertical and horizontal. Similarly, even for the bottom connection, select generic fasteners. Once you are done selecting generic fasteners, you need to select the screw type. So I'll be selecting number 10 screw, and so as you can see my stud data, only level 8 is 33 KSI, whereas all of the rest are 50 KSIs. So let me go over here. and I'll select number 10 screw for the top level, whereas for the rest of the levels I'll have number 10 50 KSI 54 gauge. Similarly, you will do the same thing for the bottom connection too. That needs to be number 10 43 mil, number 10 16 gauge 50 KSI. Once this information is inputted, you can go to summary report, go back to your load data. Is there something that we are missing? Oh, it says error level 2 top strap connections when it's giving me some kind of error. Let's figure out that. What's wrong with strap data? Two sides. Why? It's giving me error for level 2. So this needs to be wells. Fine. Yeah, and this needs to be wells. Okay. Now go to summary report, or you can do, let's see if generic fasteners with thicker gauge works. No, it doesn't. Alright, so let's go to summary report now. So here you have your summary report, total 8 levels, height of each level and width of the panel, inputted loads, seismic factors, design parameters, nothing but. You didn't have any additional cord axial loads and movements. You have your strap design over here, like strap inputted parameters. The next is the tensile strength of the strap. So this is available strength, whereas this is the strength this is the wind load that's coming into it. It creates a tension force in there. Then the next one you have is strap connections. So we didn't select wells. Now as you can see, for top of brace connections you have vertical and horizontal. So for studs you need 5 screws, for horizontal you need 5 screws. Similarly you have rest like those, okay, and also bottom of brace connections, the quantity of screws, this will be similar to the top of brace connections. The bracings provided, and then next you have is your load factored cord compression loads, and then you have your interaction ratios. So coming to hold downs, you may need to manually check for hold downs, like based on the uplift. So as you can see, your uplift over here is 3000 pounds, and you need to subtract the dead load that comes on that wall. Dead load on that panel divided by 2 needs to be subtracted from this uplift, and then the hold down needs to be decided based on the net uplift capacity, because over here you cannot enter that dead load. If you enter dead load in additional applied coaxial load, it would consider that load being applied on the end studs and which would make our interaction worse. So you need to apply your dead load, like you need to subtract your dead load manually and select your hold arm from Simpson strong tie catalog. So this is how you do a multi-story Xbrace shear wall in CFS Designer. If you have any comments, please post below. Thank you for watching the video.